I have 8 days left. That's how long I got to finish a medical device that I've been building for the last couple of months, and get it working well enough to submit to an international conference on the 20th. But I'm facing a huge issue. This is a pinch strength meter I built from scratch. It measures how hard can someone pinch precisely, and tracks that over time with clinically useful parameters. I've taken it from a mess of wires on a breadboard all the way to a custom circuit board. But there's one problem left standing between me and the deadline. And it's the hardest one. So last year, I came up with the idea of creating a data logging digital pinch meter with the usage of a load cell based force sensing circuit, signal amplifier, wireless data transmission, and a software interface for simultaneous visualization and data recording. I had no previous experience in creating anything before in my life, so I knew I was in for a wild ride. That's when I discovered Arduino and realized it would be a good fit for my projects. So I started by building simple circuits on a breadboard. After a bunch of trial and error, I managed to complete my first prototype, and I was very proud about it. Now that my first prototype was done, it was time to level up, because a breadboard circuit is not portable. I needed a way to shrink it down, so I started working on perf boards. Basically, a portable version of a breadboard. It's much less wider and it's very easy to move around. That's when I was introduced to soldering. And yes, I've never soldered anything in my life ever before. At this point, you shouldn't even be surprised. After hours and hours of work, I just couldn't get the perf board to work. It was very messy, so I came up with another solution. Building a custom PCB. PCB stands for printed circuit board. Since affording a PCB was expensive in my country, and ordering it abroad was even more expensive, I had to make it myself. So I got my iron, my acid, with all the chemicals I had, I went to the school's garden and conducted my experiment there, but I failed. The reason I failed is because I was relying on AI's guidance a lot. I should have done more proper research and should have had my chemicals ready. I misunderstood how you conduct the experiments, and at the end, I failed. So, I tried again. With the help of a friend, we actually managed to create the PCB, and it worked flawlessly. Now, all there was left to do was put in the components in my PCB, but because I was trying so hard with the perf board, I accidentally burned out all of my components. They were heavily damaged and they were not working. So I got a new pair of every single component and finally finished my prototype. And it worked. It was one of the best feelings I've ever had. Finally, all there was left to do was writing the software. The hardware is only half of it. The software takes a raw force signal and turns it into something clinically useful. The real biomarkers, such as the peak force, average force, area under curve, the slope. The device moves through defined states, which keeps the readings clean and repeatable, instead of a chaotic stream of numbers. Everything was going great and I was finally finishing my prototype. I even 3D printed a box around it, until this happened. Signal loss. I had to cut open my 3D printed box, replace the load cell, try again, and it only offered a temporary solution, because after a couple days, it broke down again. And here we are today. The hardware part is done. The software part is also done. And for some reason, this load cell and the amplifier are just giving me constant problems. Pretty much every time I work with this project, I always check my PCB for contact problems, because one small contact error and the whole circuit doesn't work. But for some reason, for the last couple of days, I have not seen any contact errors with my PCB, but it's not working. It's giving me a fixed random number, and I don't really know what the problem is, the amplifier or the load cell. But one thing I can say for certain is load cells are very, very annoying to use. Which brings me back to the problem. To submit this, I need a calibration table. A set of known weights mapped to the device's readings. So anyone can trust that when it says X, it means X. And that's where I'm stuck. I got 8 days. I need my device to work to do the calibration. The deadline is in the 20th, and I'm going to be at the lab every single night. Right after I do my 8-hour internship. I'll make a follow-up either way, whether I get the clean dataset and submit it, or I don't and I tell you exactly what went wrong. I'll see you in the next one.